We are in 14.2. So the rabbit population in the national park rises and falls throughout the year. Population has a minimum of 6,000 rabbits in December. As the weather gets warmer, food becomes more available. Population grows to a maximum of 16,000 in June. And so what we said is before we even do any math, we can just read this and see that in times of 0 months, there are going to be a minimum of 6,000 rabbits. And in June, which is 1, 2, 3, 4, 5, 6 months, we know that there's going to be 16,000. Now we can actually test this by plugging those in. And so we're going to do 2 ways. First, we're going to plug in and do with a calculator, and then we are going to plug in and use the unit circle so that you guys can see both ways of how this unit circles works. So here we go. If you plug in 0 to this, you plug in 0 right here, this goes away and it turns into just a 0. So 0 minus pi over 2 makes this become 5,000 times the sine of pi over 2, negative pi over 2, excuse me. That's very important. Plus 11,000, which this is the formula they gave us. We're just plugging in using. So in your calculator, the first thing I need you to make sure you do right now, everyone, take your calculator out. And right now, if it's on, does everybody see the DEG?
Yeah.
That means that you are in degrees. We are not working in degrees. We are working in what? These are radians right here. That's how I know what mode my calculator has to be in. We need to check, and you need to check on the EOC. I'm sure that there's a button for the calculator to change from degrees to radians. And so I'll show you where there's practice tests and how you can see the calculator that is actually on the real EOC. And you need to check, and that's one of the things you need to look for is how do I change this to the degrees? How do I change it to radians? So you're going to hit mode. And then do you see the little 5 that says rad next to it? So hit mode and 5, and now you see the RAD. Okay? So what you're going to hit right now is you are going to hit shift the EXP. Because right above the EXP you see the pi symbol, correct? EXP down at the bottom. Last row. So shift EXP. So now you see pi, correct? Then you're going to hit divide, and then by 2, and hit equals. You guys with me on this if you have questions? Now, so we've got, so on your screen you should see 1.570796, blah, 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 yes? Divide by 2 after that. After you get the pi on there, divide by 2. So now you got 1.57. Does everybody have that? You are then going to hit the plus or minus symbol, which is all the way to the left, 3 down. So now it should say negative 1.5. Now I need to do what? So I've got, all that's in my calculator is this right here. So now what do I need? What do I need before I do any multiplication? What do I need? I have to take the sign of that number. So you're going to hit the sign key. And when you hit the sign key, what pops up? Negative 1. Now, you are going to take negative 1 and times it by 5,000. You get a negative 5,000 plus 11,000. And when you put those together, you come up with the 6,000 that we said should be there. Does everybody understand how to input these using the calculator? Yes. Okay. Now let's go back and do the same exact problem, but minus the calculator. Because that's what the unit circle is there for. The unit circle in the whole study of trig is to be able to use this, and you don't even have to have a calculator to do some of these calculations. So let's go back to right here. Does everybody see where it says, I want the sine of negative pi over 2? Yeah. So let's go to our unit circle. What does it mean? What does it mean to go negative pi over 2? Well, If I go positive pi over 2, I would go this way, and since it's a sign, I would go for the y value that's right there. But it didn't tell me to go positive pi over 2. It told me to go where? And so what would I do instead? But did you see how far I went? I'm going to go that same distance. I'm just going to go to the left, or counterclockwise, or clockwise, sorry. We're going to go clockwise instead of counterclockwise. So instead of going this way, pi over 2, when I go negative, I'm supposed to go this way. So this is the one I'm going to use, because it's a negative pi over 2 that I'm supposed to be going. And negative is the thing that tells me to go this way, and pi over 2, this distance, I use this distance to realize, oh, it's 90, right? So I know I'm going to go 90 back this way. You guys following me? Yeah. So I use the forward way to figure out how far I'm supposed to go backwards. Because if I look at this, and I go, oh, where's pi over 2 backwards? This doesn't say pi over 2 negative, does it? So I go my forward way to realize, oh, this is how far I have to travel, but it's got to be in this direction. You can use a unit circle from your brain. No, that's how this works, because you're not going to get the unit circle on the EOC. Whenever you go into trig, if you're going onto trig, you won't get the unit circle. In fact, that's why the first day of trig, when I walked in, the teacher gave it to me and said, memorize this, because you have to have it for the rest of this, for trig. Now, what happens with this is we wanted the sign of this, correct? What's the sign? The y value of this coordinate, right? Well, what's the y value right here? And when you put it in the calculator, what did you get out? So you don't even have to, if you know the unit circle, you don't even have to waste the time doing the calculator. You can just know that the sign of negative pi over 2 is a negative 1, and you can get that information from this unit circle. Does that kind of make sense of how this thing is used? So what we found when we did that was we just realized that the sign of negative pi over 2, we just figured out that this is really equal to negative 1. And then you take that negative 1, again, just like we did here, and we took negative 1 and times by 5,000, got a negative 5,000, added it to that, and it still pops out as 6,000. With me? All right, so let's try 2. Let's try February. With an R. Just wanted to let you know. So, if we do this, it would be 5,000 sine of pi over 6 times 2 minus pi over 2 plus 11,000. Now notice, if you've been practicing with your fractions, like I've asked you to, you realize that eventually when you get to math, you're forced to use them. Yeah. You can't change this to, it's going to be worthless, especially if you're trying to use the unit circle here. It's going to be pointless to change this to a decimal. There's just no freaking decimals on the unit circle. Yeah. Oh, it should be 6. Thank you. So then right here, I go ahead and what does this become? Pi over 6 times 2, what does that really become? What does pi over 6 times 2 really become? It really becomes 2 pi over 6. How do you multiply fractions? Top times top and bottom times bottom. We've done that all year long. Now, is this reduced right here? Yes. Is this reduced? No. I'm not going to worry about reducing it right now, though. Does that make sense? Because I still have something to do to it. You could reduce it and it would work out, but I think actually if we reduce it, you're going to come back to this anyway, so let's leave it like that. So does everybody see I have 5,000 times sine of 2 pi over 6, and I go minus, wait. If I'm going to subtract these two, what do they have to have? And is that a 6? So I have to multiply it by 3 and multiply this by 3, so then I get 3 pi over 6 plus 11,000. Is everybody with me? $5,000 sine, and then this becomes negative pi over 6 plus 11,000. Okay, now I'm going to take out my handy dandy calculator, right? So here we go. You're going to hit, what do I hit to get to this? Shift EXP, divide by 6 equals, now what do I hit? No, you don't hit that sign yet. Be careful on this. What do I have to hit first? It is a what? Negative. So make sure it should say negative 0.5 something. Everybody with me on that? Now what do I hit? So I'm going to hit sine, which should be a negative 0.5, right? Times this by 5,000. Hit equal. Come up with negative 2,500. I add 11,000, and you should get that right here. There's 8,500 rabbits. How are we doing? All right, let's go back for just a second. We don't have to do too much. We've already done our math, but let's talk about how to do it on the unit circle again. I'm going to look for the sine of pi over 6. So the way I do that is I go to my unit circle. And go, okay, I'm looking for a negative, so I know which direction I'm supposed to be going. Pi over 6 is really just going like 30 degrees that way, right? But that's a positive pi over 6. Am I supposed to go that way? No, so I know that's how far I'm going, but I'm going this way. You guys understanding what I'm doing here? So then I know sine is the y value, and again, if you look at it, it's a negative 1/2, just like when we put in the calculator, that's what we got. So you see how this unit circle is to be used. Now, what if they had cosine? Then I would be using the x coordinate for this, and that's the only thing that would change. Okay? So that's how you use the unit circle. If I said I wanted the sine, or if I wanted the cosine of pi over 3, what would your answer be? Your answer should go right here. That's how far I need to go. Cosine is the x. This is just 1/2. I haven't even decided what we're going to do about this test. Okay? I just want to make sure we're understanding. Yes? I know, contrary to popular belief, my favorite thing are not tests. I would rather you guys just worry about content. And the test, I think, should follow after. So do you think that we could fill in the rest of this chart? Do we understand how to do it? So they come up with all these numbers doing that. Just doing the stuff that we did. I didn't want to take the time. I think that would take too much. That's how they got all those numbers. And if I go ahead and I go down here, you can see there's that wave. Now, do I have a midline right here? Does everybody understand? I don't have a midline. Okay? So what I would probably do personally is I feel like it's hard. I don't understand why they asked this question. How has the function been translated vertically from the basic sine function? You do realize that it's gone up, right? Yeah. And actually, it's also gone over. Remember? Yeah, we're going to talk about that. That's the amplitude. But what we're talking about is the normal sine function looks like this. Right? And it keeps going, and this keeps going. But it looks like this. So this, do you see the top, like this wave right here? Like the top half and the bottom half? Do you see this top half starts right here? So if I moved this just straight up, it should look like this. You see that? But it doesn't start like that, does it? It starts at the bottom. It would be like this part right here is now over to there and shifted up. Are you following me? You guys with what I'm talking about? So what I would do personally is I would find this amplitude. Because if I find the amplitude, I can find the midline. Once I find the midline, my midline runs all the way across like this at 0. If I find my midline to be up, and I see that it's up to 11,000, that's how much I know this thing has been shifted up. Because the midline is just going to go up or down. Is the midline going to be affected by how much? Because this thing was also moved to the left and right. You guys realize that? So is the midline going to be affected by that? No, because the midline runs the whole length of this thing. So sure, I can move this over a little bit, but the arrow keeps on going forever that way anyway, so it's not like you can move it. It's a line. You guys follow what I'm saying? So I would find the amplitude first, and the way we find the amplitude is we take the maximum and subtract the minimum. What did we say the maximum was? 16,000. And we subtract the minimum, which was? And so we get a 10,000. Is that our amplitude? That's from here all the way down. Where's our amplitude supposed to only run to? The midline. Does everybody understand that? So what do I have to do with this finally? And so I realize that my amplitude is 5,000. That's a comma. I know. It's terrible. Struggling. So does everybody see where we got the amplitude from? Yeah. Now, what does that mean for my midline then? That I would go from here up 5,000. So I think, what are we going by? Are we going by 1,000? So 6,000, 7. So 1, 2, 3, 4, 5. Right here is my midline. And that makes sense because if you look at the top function, the top of this wave and the bottom of those waves, they look equal, correct? So it makes sense. And where does that put my midline at? My midline is at 11,000. If it's supposed to be at 0 and it's now at 11,000, this function has been translated up 11,000 units. That's how I would attack this problem. I don't know how they got the midline. I don't know how they knew that that was translated up 11,000. Personally, I don't know how they did that. Just randomly. I don't know. Now, this one is very tricky. This next question is definitely very tricky to me. There's two ways we can attack this problem for a period. Period is how long it takes to do a full rotation all the way up and all the way down, correct? Well, what's the problem with where I start at? It doesn't start at where the midline is, right? Which is right here. Like this would be the starting point. You with me? And then I would end all the way to right here. So one way is to count from how many months this is to how many months this is. So this is on the third month my new cycle starts. Does that make sense? So there'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And to realize that this distance is 12 months, so it takes 12 months for it to go all the way up and all the way back down. Are you guys following me? Okay, that's one way to do this. Or another way is to realize, hey, if I start here, my time period starts here, then I could end right here, and that would be the same. Do you see how this half right here plus this half right here would make my bottom view? You get what I just did? And so if I look at how long it takes to complete that, I also get 12 months. And I'm going from 0 to 12, so I know it's just 12 months. I don't care which one you like. You can do either one. But that is what a period is. how long it takes to create a bottom and a top of my wave. Good? All right. Now, oh, I lied. I forgot. I do know how they did this. Here's how they did the, I forgot they gave us this equation. The other one doesn't give us the equation. They gave us this equation. So it's easy to see that it was shifted up 11,000 because remember, from yesterday, this right here is our, how much it goes up or down, vertical shift, correct? This right here is how much it is going to be in this. We'll talk about this one. This one's a pain in the butt. This one right here, notice is our amplitude, correct? Don't pack up yet. I still got a minute. Don't be rude. You're on video. You just admitted to being here. All right, now the phase shift. The phase shift is a little bit more of a pain in the butt. The reason why it's a little bit more of a pain in the butt is you see this pi over 6 right here? And do you see this right here? I've got it to be where it's just x in there by itself with the phase shift. So what they do is they say, hey, what do these guys have in common? And they realize that you can really rewrite pi over 2 using pi over 6. This is going to become, you can rewrite it as 3 pi over 6. Are you with me on that? Because these would cancel, so it's like I'm unreducing this fraction. And then when I rewrite it like that, that really could mean 3 times pi over 6. Do you guys see how I did that? You're breaking this out, remember? As long as I can go, if I can go this way, then I can go backwards. I can unsimplify it. And the reason I'm unsimplifying it is, do you remember when you did this? 5x plus 10? Yeah. You said, hey, what do these both have in common? A 5, and then you're left with x plus 2. You factored out a 5 from this one, and you factored out a 5 from this one. What are we doing right here? Is we're saying this is pi over 6x minus 3 pi over 6. What do both of these guys have in them? Hold on. No. They have a pi over 6. So I factor out the pi over 6. What am I left with? I'm left with an x minus 3, which then that's able to see that you have 3 months is the phase shift. What do we think? Good? We'll finish this. They gave us 2 days to do this anyways. So we'll finish this up tomorrow.